we'll be discussing about amyotrophic lateral sclerosis, which is otherwise known as Lou Gehrig's disease, which is a progressive neurodegenerative disease involving both upper motor neuron and lower motor neurons. It affects both upper motor neurons and lower motor neurons. So it results in muscle weakness, atrophy, and eventually lead to respiratory failure. So let's look into the details of the disease, pathophysiology of which involves degeneration of both upper motor neurons and lower motor neurons in the brainstem and spinal cord, and this leads to a combination of spasticity, which is due to involvement of upper motor neuron, and muscle wasting, which is a feature of lower motor neuron involvement. Looking into the molecular cellular mechanisms, it is due to glutamate excitotoxicity. Second is oxidative stress. Next is protein misfolding and aggregation. These involve proteins such as TDP43, SOD1, FUS. Next mechanism is mitochondrial dysfunction, and last one is neuroinflammation and microglial activation. So these are the cellular mechanism which leads to degeneration of upper motor neuron and lower motor neuron, which in turn is a feature of ALS. Coming to genetics, 90 to 95% of the cases of ALS are sporadic. Only 5 to 10% is familial, and of this 5 to 10%, the genes involved are C9 or 2, which is a hexanucleotide triple G GCC repeat expansion. It's the most common mutation in ALS and frontotemporal dementia. So this mutation is seen in ALS as well as frontotemporal dementia as well. So dementia would be a feature of this mutation, and this mutation results in toxic RNA foci and dipeptide repeat proteins. Next mutation is SOD1, which is mutation in superoxide dismutase 1, resulting in oxidative stress due to gain of function effect linking to early onset ALS. So this is a feature of SOD1 mutation, early onset mutation, whereas C9orf was the most common mutation, and it was also seen in FTD, frontotemporal dementia as well. Coming to the next mutation, that is FUS mutation, that is due to mutation in RNA binding protein, which disrupts the RNA metabolism and protein homeostasis. The next mutation which we missed is TDP43 proteinopathy. TDP mutation proteinopathy. So this is TDP43. The mutation is in TDP43 lead to aggregation of TDP43, a DNA RNA binding protein, seen in both familial and sporadic ALS. Leads to aggregation of TDP43, both in familial and sporadic cases. Next is ALS2 and AMG. ALS2 is alsin mutation. This also leads to early onset ALS, and that is androgen mutation implicated in RNA metabolism. It's also associated with both ALS and Parkinson's. So C9orf was associated both ALS and FTD, frontotemporal dementia. SOD1, that is superoxide dismutase 1 mutation, is associated with early onset ALS. FUS is a mutation affecting RNA binding protein. TDP43 mutation results in accumulation of TDP43 and is seen both in familial as well as sporadic cases of ALS. And ALS2 results in early onset ALS like SOD1, and AMG mutation is seen in both ALS and Parkinson's. Coming to clinical presentation. The ALS comes in presentation in both mid and late adulthood, with progressive symptoms classified based on upper motor neuron and lower motor neuron. So the features of upper motor neuron are spasticity, hyperreflexia, that is brisk, deep tendon reflexes, Babinski sign, extends the plantar response, The lower motor neuron signs are muscle atrophy and fasciculation, flaccid paralysis, and hyporeflexia. Coming to specific patterns of presentation. So initially, the presentation would be limp presentation. That is limp onset ALS. The weakness would come initially in the form of weakness in arms or legs. And the second one is bulbar onset ALS, which shows features of dysarthria, dysphagia, tongue fasciculation, more common in older adults. Then as respiratory onset ALS, this presents with dyspnea, but is associated with poor prognosis. Syndromes or named phenomena associated with ALS are split hand syndrome, which is weakness and atrophy of the lateral hand muscles, thenar and first dorsal introject compared to the middle hand muscles. And the second one is flail arm syndrome, which is symmetric proximal arm weakness, a subtype of ALS with slower progression. Flail arm syndrome is slow progression. Split hand syndrome results in weakness and atrophy of lateral hand muscle. Next is flail leg syndrome. Flail leg syndrome is similar to flail hand syndrome and is associated with a slow progression. The disease can overlap, ALS can overlap with frontotemporal dementia when there is mutation in C9 or 72. Coming to diagnosis, it can be diagnosed, it remains a clinical diagnosis but supported with L-Escorial criteria. L-Escorial criteria, which involves evidence of both upper motor neuron plus lower motor neuron and progressive spread of symptoms. Progressive spread of symptoms, absence of other disease explaining symptoms. Investigations are progressive symptoms and absence of other disease. So electromyography shows denervation and reinnervation both pattern. Denervation and deinnervation pattern. MRA show structural lesions but may show cortical spinal tract hyperintensity. Coming to genetic testing, ALS mutations can be tested. CSF study show elevated neurofilament light chain. Coming to treatment options, the treatment aims to slow progression and manage symptoms. So available treatments are riluzole, which reduces the glutamate excitotoxicity, which extends the interval by just 2 to 3 months. Edaravone is the mechanism of which is free radical scavenging, reducing oxidative stress, slow functional decline in early onset ALS. Emerging investigations therapies include tofersen, the mechanism of which is antisense oligonucleotide target SOD1 mutation, reduces SOD1 levels in familial ALS, FDA approved in 2023. That is tofersen. Gene therapy which approaches targeting C9 or 72. Stem cell therapy, which includes neural or mesenchymal stem cells, aims to replace damaged motor neurons or modulate inflammation. The other one is AMX 0035, Relief Viro, which is a combination of sodium phenylbutyrate and torosodiol. Protects mitochondria and inhibits apoptosis, which was FDA approved in 2022. Neuroprotective drugs trials investigation in getting agents like masitinib, a tyrosine kinase inhibitor, ultra-dose methylcobalamin have also been tried. It is under investigation. Symptomatic management includes spasticity management by baclofen and tizanidine, respiratory support with the non-invasive ventilation, that is bipapotracheostomy. Dysphagia can be managed by percutaneous endoscopic gastrostomy, PEG, and psychological support. Prognosis: the median survival is 3 to 5 years from the symptom onset. Better prognosis associated with younger age, limp onset ALS, and slow progression. Thank you.